So now I'm recording. Thanks, David, for reminding me. Okay. At this point, we've got some function. The classes are usable at this point now. Right? We have a no argument constructor in all of our classes. We've got some methods in all of our classes. You can, of course, add additional methods to our classes. But what I want to do now is I want to go back and add some more constructors to our classes. Constructors are pretty important when you implement your class, because they're responsible for initializing the state of the object. Right? If you can't initialize the state of your object correctly, then your objects aren't going to behave correctly when people start to use them. Okay, you are allowed to have multiple constructors in a class, but their signatures have to be unique. So the signature for a constructor is the same as the signature for a method. It's the name of the constructor followed by the types in the parameter list. Right now, because the constructor names are always the same, then all of your constructors must have different parameter lists. Right, so the types and the order of the types and the number of types, I guess, they all have to be unique. Right, so some combination of those parameters of those factors have to be unique. When you're creating constructors, you have to remember who is using your class, right? So you could create a class that just has a no argument constructor, right? And then you would force the users of your class to call methods on your objects to set up the state, to set up their objects the way they want, right? So we could provide a constructor for point 2 that always sets the coordinates to 0, 0, and then when the user wants to use the class, they call the constructor, and then they call set to change the coordinates of the point. It's much nicer for the users of your class to be able to initialize objects the way they want to. Okay. So for the point 2 class, it would be nice if you had a constructor that let the user set the x and y coordinate of the point when they first make the point. Right. But that's easy to do, right? You just add another constructor, choose your parameters. Right? So here I want the user to be able to set x and y, the x and y coordinate of the point. Right, and then you implement the constructor. Now, how do you initialize a point? Given its x and y coordinate, well, you set this x to x, you set this y to y. So here's we already talked about this in the previous lecture, but here's an example where you have to use this dot x in front of the field name, right? Because you've got two things in the class called x now, right? You've got a parameter x, you've got a field x. Inside the method, the name x refers to the parameter. The name y refers to the parameter y. So if I want to set the field called x, I have to use this dot x. Right? And if I want to set the field y, I have to use this dot y. Right? There are some common errors here. So one of the it's probably the most common error that you see is that people write x equals this dot x, right? Backwards. Right? Because you have to remember what that means. When you write x equals this dot x, you're saying the parameter x gets the value of the field, which changes the parameter in this case to 0. Similarly, if you write y equals this dot y, that sets the parameter y to 0, and it doesn't affect the fields x or y. Right? So you end up with the point 0, 0, even though it's supposed to have the coordinates x and y. The other less common error you see is that sometimes students write x equals x, right? But that does nothing, right? It doesn't matter. That ends up assigning the value of the parameter to itself. So that also does not affect the fields x and y. So what happens here when you write this line of code, right? So now we're going to call our second constructor that we've added to the class, right? So P shows up somewhere in memory. Parameters were named A and B. Nope. So if the parameters were named A and B, that was A and that was B, you can write x equals A and y equals B. The whenever you use a field, if you always write this in front of it, you'll never get it wrong. Right? So that's I guess that's the one piece of advice that I'll give you, right? So if you need to use a field, and there's any possibility of confusing the field with a variable or a parameter, right, you can always use this in front of the field name, right? And so if you get in the habit of always writing this in front of the field name, you'll never make any of these types of errors. All right, so P gets created. Right, now remember, so the variable P gets created. New runs. So when new runs, you get a copy of the class plunked down somewhere in memory, right? And that's our object. That's our uninitialized object. The constructor now runs, right? When the constructor runs, it gets the address 600, right? So the constructor down here. Oh, yeah, this one's a little different. This is good. So the constructor runs. Now the constructor, if we quickly go back, right, it has parameters X and Y. So our constructor has its own parameters X and Y, and it also has a, I guess this is a parameter or a variable called this, right? This points to or refers to the object that's currently being initialized. So it points to that object there, right? The parameters X and Y of the constructor are initialized to -1 and 1.5. So there you see the values of X and Y, right? But this X and Y is different from that X and Y. The constructor now runs. So the constructor body runs, and what does the constructor do? Right, the constructor says this dot X equals X. Right. So that's that object there. So we come up to here. This dot X, so that's that field right there. Right. So this dot X equals X. Right. Now for the constructor, X is this value here. Right. So that value there gets set to -1. And the next line says this dot Y equals Y. Right. So this, we come up to here, dot Y means that field there. Right. Equals Y. So for the constructor, Y is 1.5. So that value there gets set to 1.5. Do I do the rest? Yeah. Okay. So the constructor finishes running. New finishes running, returns the value of the constructed object, right? So all of this over here becomes equal to 600A, right? Address 600. And so that's what P gets the value of. So P points to this object here, which has the coordinates -1 and 1.5. So in our constructor, because we have parameters that have the same names as the fields, the parameters take precedence over the fields inside of the method. Right? So they take precedence over the over the fields. If you read the Java standard, the Java language standard, it says that the parameters shadow the fields, right? Or the parameters hide the fields. Right. So when shadowing occurs, you have to use this to refer to the field. Right. And as I mentioned in the previous lecture, this turns out to be very common in Java. So when you make these simple classes like point, right, or counter, it's often the case that the writer of the class will choose parameter names that are the same as the fields. Right. It happens less, I think, in other languages, but in Java, it turns out to be quite common. Now, why did we add this constructor to the class? So remember, we didn't have to add this constructor to the class, right? We added it so that it would let users of the class be able to create points more easily, right? So, for example, right? Suppose suppose we just had the no argument constructor, right? So suppose we just had the point2 constructor with no arguments here, right? In order for someone to make a point whose coordinates are -1 and 1.5, they'd have to create the point, and then they'd have to call set themselves, right? You can replace all of that now with just a call to the constructor. What with a call to a different constructor? So it saves the users of your class some writing, right, or some work. It also makes the class a lot more pleasant to use. So that's one type. So that's one particular constructor for the point2 class. There's no special name for the constructor that we just implemented, right? It's a constructor. It has some parameters, right? The parameters correspond to fields of the object. So there's no special name for that constructor. It's just called a constructor. There is a second type of special constructor in the Java language. So that's the constructor called the copy constructor. The copy constructor lets you copy another object. That's why it's called the copy constructor. So it initializes the state of an object by copying the state of another object of the same type. You can identify a copy constructor because it has exactly one parameter, and the type of the parameter is the same as the type of the class. Right? So the copy constructor for point2 takes in a point2 object as its input. So for example, right, if I want to copy the coordinates of another point called other, and I can do that, or I can give people the ability to do that by creating a copy constructor. So it's a constructor. Parameter type is the same as the class type. So in other words, that matches that, right? Which also matches the name of the class. That's got some name. So this is called other in this case to indicate that you're copying another point. Right. Now, how do I copy another point? Well, I just copy the x and y coordinates of the other point. Right. Now, how do I get to the x and y coordinates of the other point? Right. I can write other.x and other.y in this case. Right. So I'm allowed to access the fields belonging of the object that this refers to, right, by writing the name of the field. I can write this dot x equals other dot x, and I can write this dot y equals other dot y, right? I'm allowed to do this because I'm inside the point2 class, right? So within the point2 class, you can access the private features of any point2 object. Within the class, it's perfectly valid to write other.x and other.y, right? Even though x and y are private, right? So private simply means that the fields x and y are not visible outside of the class. Inside the class, they are visible even if they belong to another object. Now, one of the common errors you see in this constructor here is that new programmers will write other.x equals this.x and other.y equals this.y. Whatever you do, don't write that, because what ends up happening is you end up changing the coordinates of the point you passed in to 0 and 0, right? And you don't change the coordinates of this.x or this.y of this point, of the point that's being initialized. Right? So whatever you do, don't reverse the order of the assignment. In this example, if you wanted to, you can write x equals other x and y equals other y. Right? So there is no confusion between the name x and the name other.x. Now, the copy constructor also makes users makes it a lot more pleasant to use your class. Right. So, for example, here's a little main method. It makes a point p. Right. Its coordinates are -1 and 1.5. Right. Here's a point q. Right. And it calls the copy constructor. Right. So you can so it sets the coordinates of the point q to be whatever the coordinates of point p are. Right. So when you print out p and q, you get the same string being printed out. Right. -1, 1.5, -1 and 1.5. Right. And that's because q is a copy of p. Now, if you change p, right? So we change p. So I'm going to change the coordinates of p to 99 and 44, and then print out p. Right. Coordinates of p are 99 and 44, so set seems to work correctly. Right now, q is a different point than p, right? So its coordinates don't change. You've got two different points that are originally equal, so they have the same coordinates. right? If you change either point, so in this case, if I change P, the other point does not change. Right? So these things are really two independent objects. Okay, now let's go back and quickly look at our constructors. So actually, you know what? Let me just, I'm gonna, give me a second here to pop open Eclipse. So I'm just gonna open up Eclipse and look at the class directly. So what we want to look at all three constructors that we've implemented so far. Yo. That. Wait, here? Here, no. Here. And here. And then, sorry, while I adjust the font. There. Okay. And we can get rid of this. All right, so let's look at our three constructors. So there's number one. I'm actually going to, can I do this? I can do that. Perfect. So I'm just going to collapse the comment so that we can see all three at the same time. Oh, I've actually changed this. Let me set this to what I have on the slide. Oh. Okay, so that's what we have for our three constructors, right? All three constructors, if you look at what's written in them, right, they're all almost identical, right? The no argument constructor sets this x and this y to something, right? The second constructor sets this x and this y to something. The third constructor set this x and this y to something, right? So in other words, the bodies of all three constructors are duplicating them, are almost duplicates of one another, right? So it turns out we're repeating ourselves over and over and over again in the three constructors. So whenever you see duplicated code, right, and it doesn't matter what language you're programming in, right, as long as the language that you're using has something like functions or methods. So whenever you see duplicated code, right, you should always consider moving that duplicated code into a single place, right? So in Java, you would move it into a single method or constructor in this case, right? And then whenever you need to use that code, you just call the method or constructor. Okay? So here we've got three constructors that more or less do the exact same thing. So what I would like to do is I would like to implement one constructor and then have all of the other constructors call that one constructor. Okay? And so the mechanism in Java that lets you do that is called constructor chaining. So rather than showing you the slide, let me show you how you do this in Eclipse. Okay, so you look at your three constructors and you ask yourself, right, which one of these is the most general constructor? Right. So here's the constructor. It sets x and y to 0 and 0. Right. So that sets x and y to some pretty specific values. Here's a constructor that sets x and y to whatever other x and other y are. Right. So again, this is pretty specific, right? I have to pass in a point2 object in order to use this constructor. This constructor, though, it takes in individual x and y coordinates. Right. So what I'd like to do is instead of writing that in that constructor, I would like to somehow call this constructor and pass in 0 and 0. Right? And similarly for this constructor, rather than writing those two lines of code, I would like some way to call this constructor here, passing in other x and other y. Okay? So in other words, from this constructor, I would like to call this constructor. From this constructor, I would like to call that constructor. So the way you do that in Java is you write the following. Let me comment out this instead of deleting it. Oops, sorry. Instead of writing that, you can write the following. And instead of writing this x equals other x and this y equals other y, you can write the following. This, other x, other y. That. Now let me get rid of this so that we can actually see everything. Okay, there we go. And get rid of this. Okay. So here's another example of the keyword this. Java is kind of so Java has in some cases Java recycles keywords, right? So in other words, it uses a keyword for more than one thing, which is a little bit confusing when you first start using the language. So here, the language designers have decided to recycle the keyword this, right? Because here, this means this refers to the object that was used to call the constructor, right? In this context here, this is just calling another constructor, right? So in other words, this is the syntax that you use to call another constructor, right? So what that does there is it calls that constructor here. Now it's still the same object that's being constructed, right? So when you write new point two round bracket, right? We call another constructor, right? But now it's this constructor that ends up doing the work of filling in the object that's being initialized. So what happens? Well, we pass 0 and 0 to this constructor here. So this constructor here ends up setting this x to 0 and this y to 0. In the copy constructor, right, we can call the second constructor, right, again using the keyword this, right, and now we pass in other x and other y. So what happens here is this constructor runs and it sets this x to other x and it sets this y to other y, right, and now you've eliminated those two lines of code and these two lines of what are essentially duplicated code, right? And you've eliminated these two lines of, again, what are essentially duplicated code, right? And we've replaced it with a call to the second constructor, right? Now, in this example, that's an example of what's called constructor chaining, right? So when a constructor invokes or calls another constructor, right, then we use the term constructor chaining to describe what happens. Now, if you decide to do this, okay, so when you decide to do this, I'll get to this. I'll get to your question in a second, Noah. When you decide to do this, there's only one place you can do this, right? So the only place you're allowed to do this is on the first line of the constructor, right? So that's the only place you can chain to another constructor, right? If you try to write some code before that line of code, right, then Eclipse will complain, right? So right now, right, Eclipse seems happy with our code. There's no indications of any error. If you try to insert some code here, I don't know, what code would we insert here? We just do anything. So double Z equals 1, right? For whatever reason, who knows why, right? As soon as you put a line of code there, Eclipse will immediately flag that constructor call as an error, right? So it even tells you the constructor call must be the first statement in a constructor. So when you decide to use constructor chaining, right, it has to be the first line of a constructor body. Okay. When you use constructor chaining, right, the chain has to end at another constructor eventually. Right? So in this case, we end up here in this constructor. Right? When we use constructor chaining here, we also end up in this constructor. Right? There's only 3 constructors in the class, so the chain has to end here. Right? In other words, if you try to do something crazy, what would you try to do here? Let's just try to insert another constructor chain here. Right? This doesn't make sense, but let's suppose I try to chain back to the first constructor. Eclipse will flag that as an error. Right? It tells you there's a recursive constructor invocation. Right? Because what happens is if you call this constructor here, it chains to here. This one chains back to this one here, which chains to here, which chains back to this one here, and so on and so on and so on. Right? So at some point, the chain has to end. What else do I want to say about constructor chaining? All right, so let me look at Noah's question. Is it fair to think about this as classes being callable? Constructors just methods over. No, so everything you wrote, well, so number one, so constructors aren't methods in Java, right? The language standard is very clear on that, right? It says constructors are not methods. Classes aren't really callable, right? So you can call a method or you can call a constructor. Saying that you can call a class doesn't make sense in Java. So it's not the same as the Python call, for example. Right. Okay, so the other thing you cannot do, right? So a constructor chain has to happen from within another constructor, right? So for example, if you're in a method somewhere, you can't chain to a constructor using this. So the only place you can do the constructor chain is on the first line of another constructor. And if all of this seems very strange, there actually is a very good reason why this happens. But to explain why that happens, we need to talk about material in part 3 of the course. So you need to learn about inheritance before you see the actual reason why all of these rules are in place. I guess here's another picture of our class, right? So you can rewrite the first 2 constructors to chain to the second constructor, right? As shown here. Now, in this particular example, it doesn't really save you a lot of code, right? It basically saves you 1 line of code in each constructor, right? Because you still need one line of code to chain to the second constructor here. Right, and each constructor body only had 2 lines of code to begin with. So it actually doesn't save you a lot of work here. Where this becomes more important is when you start to create more complicated classes, right? So if your class has several fields, right? So in other words, more than 2 or 3, right? Then when you start to write your constructors, then it becomes really obvious that all your constructors are doing something that's very similar, right? And so that's when constructor chaining really starts to help you. Right? Also, when you start to write more complicated constructors where you have to validate the inputs to the constructors, right? Constructor chaining really saves you a lot of work because then you only have to validate in one constructor and you just have all the other constructors call that one constructor if you can. Right? It's not always possible to do because of that restriction that you can only call another constructor from the first line of a constructor. But otherwise, constructor chaining can save you a lot of work. So here, this is mostly for illustration purposes. Same with the counter class, right? The counter only has one field, so constructor chaining is not going to save you a lot of work. Right? But if you wanted to do it, we can go ahead and create a constructor that initializes a counter to some specified positive value, right? So instead of the counter starting at 0, we can start at, say, 10, right? And we can also implement a copy constructor. There is our no argument constructor, right? And originally we had this value equals value, right? Now I'm going to write this 0, and I'm going to add a second constructor that takes in a value. Ignore the validation for a second. Okay. So what does this constructor need to do? It needs to set this value to whatever value that is. Right? So this value equals value. Again, notice we have to use this because we have a parameter name that's the same as a field name. Right? Now, our counter class is a little bit different than the point2 class because the counter class has some restrictions on what values this dot value can have. Right. So remember, our counter counts only non-negative values, right? So in other words, this value is never negative. If you choose to implement this constructor, right, you now have to make sure that you never set this value to a negative value. right? Because then you end up with a counter whose state is invalid, right? All of the documentation for the counter class says that the counter always represents a non-negative value. So if you let somebody set this to a negative value here, you now have a counter class. You now have a counter object with a negative value, and that doesn't make sense according to the documentation of the class. So here, it's critically important that you validate the parameter coming in. Right? Check, is that parameter less than 0? If it is, we throw an exception to prevent the object from being initialized. Okay, so remember when an exception is thrown, right, Constructor immediately stops running. Right? And I guess the Java virtual machine looks for something that can handle this exception. Right? If it doesn't find anything that can handle the exception, the program stops. Right? The program crashes. Only after you validate the parameter can you set the input value. Can you set the field value to value? Right? So some common mistakes that are made here. New programmers will often write if this value is less than 0, then throw an exception. That doesn't make any sense, right? You don't want to validate the field. You want to validate the parameter, right? So not if this value is less than 0, right? It's if value is less than 0. Another thing new programmers will do is they'll take this line here and put it up here, right? So they'll write this value equals value, and then they'll validate the parameter. You don't want to do that because it's possible for the caller of the constructor to catch the exception, the thrown exception, right? So we haven't talked about this yet in the course. We'll talk about it a little later. You'll also see it in the lab 3. But if you initialize the value of the counter here, and if someone calls the constructor and catches the exception, they'll end up with a counter whose value is negative. Okay? So you have to make sure to do the setting of the fields after any validation occurs. Right? Don't do it before any validation occurs. Finally, the copy constructor you can implement in the same way that you implement the .2 copy constructor. Right? Chain to the second constructor, pass in the value of the other counter. Right? Again, you're allowed to access the value of the other counter because you're inside the counter class. Right? So you have access to that object's private features. And I guess that's it. Oh, it's 20 after the hour, so that's good. So that's it for today's lecture. Does anybody have any questions about, I guess, constructors or methods in the class?
Yeah, sorry, I have a question about the assignment.
Okay, let me deal with that in a second.
Yeah.
Anybody have any questions about the lecture? All right, I think I may have forgotten to tell you that Lab 3 is up. Did I tell you it's up? It's up. It's short. So it'll take you probably half an hour, or, well, certainly less than an hour to do. Oh, sorry, it's coming up. It's not up yet. It'll be up later this morning or early this afternoon. All right, question about the assignment.
Yeah, in the update letters method, you say that every green or yellow letter in the guess is added to the set included, and every gray letter in the guess is added to the set excluded. What do you want us to do in the situation where you have duplicates? So like I did an example in my code. Let's say you have the first occurrence of the letter T is in the word, but the second one isn't because the actual word only has one letter T. Do you want us to put it in both sets, or?
No, it should not be in both sets. So if T is in the word, then it should be in the set included.
Okay, so duplicate. I have to check for duplication, and then yeah,
you have to check. So what's the yes? So you have to do something, right? So the tricky part in that method is that if you're not careful, you end up with the letter being in both sets.
Yeah. Okay.
Or I guess it's possible that you end up with the letter not being in either set if you do it incorrectly, which is also incorrect.
Yeah, I just had it that it ended up in both sets for mine.
Yeah. Yeah. So the original assignment the output from the main method also had it in both sets. And a student asked me about that, if that was correct, and the answer is no. So my original solution had an error in it.
Okay, thank you.
You're welcome. Any other questions?
Yeah, I have a question just about like, is there a overall schedule for when like assignments and labs are gonna be released?
At the moment, I can probably do it over reading week though. So the rest of the course is probably, so I can probably set the timing of all the other assignments now and labs. But it's been a big scramble because of the deferred exams up to this point. But would that be useful to you?
I mean, it would be useful for me. I don't. Hopefully, other people too.
No, I mean, so I can probably get that set up after during reading week for the rest of the course.
Okay, thank you.
All right. Any other questions? All right, super. I will see you, I guess, Wednesday.